R1, trigonometric ratios, sine, cosine, and tangent. Whenever you take the ACT, there will be trig on it. And so we need to go over some trigonometry. Okay. So let's see. All right. So trig means triangle. Triangle. And we're going to be using right triangles whenever we are talking about trig ratios. And SIN is an abbreviation for sine, so it is not pronounced sin. And the way that you do sine is opposite over hypotenuse. I'll go over that better in just a minute. COS is cosine. So whenever you say cosine, you abbreviate it COS. Whenever you see COS, you pronounce it cosine. And it is adjacent over hypotenuse. And tangent is tan, and that is opposite over adjacent. Now, whenever I was in high school learning this for the first time, what my teacher taught me was some old hippie. So sine is opposite over hypotenuse. Some old hippie caught another hippie tripping on acid. Some old hippie caught another hippie tripping on acid. So if you could remember that little saying, then you know opposite and hypotenuse go with sine, adjacent and hypotenuse go with cosine, and opposite over adjacent goes with tangent. Now you're like, well, what's opposite and adjacent? What does all that mean? Okay, so let's go on. To be able to use trig functions, you have to have a right triangle. We're always going to have right triangles on these problems, so you don't really have to worry about that. Now, to be able to have a triangle, you have to have 3 points. The right angle is not going to be basically used with any of this. We are only going to be using the acute angles in the right triangle. So let's say we're talking about angle X. I'm going to pause for just a second. Okay, I got a different pen, so maybe it'll write a little bit better. Okay, so we're just talking about angle X, not angle W, for just a second. So if it asks you for tangent of X, or sine of X, or cosine of X, we're going to be looking at where that angle is. And where that angle is determines what the 8, the 15, and the 17 are. Now, the hypotenuse is always the hypotenuse. Okay? But if you're looking at the X, or you're looking at the W, the opposite and the adjacent are going to be turned around a little bit. Okay? So whenever we're talking about angle X, 15 is opposite angle X because it is away from it. And 8 is adjacent to X because 8 is used to making up that angle. So let me erase all this stuff. Okay, good enough. And so adjacent, opposite, hypotenuse when we're talking about x. So if sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, then sine x is going to be 15 over 17, and if that reduces, then you would reduce it. Cosine is adjacent over hypotenuse, which is 8 over 17, and tangent is opposite over adjacent, which is 15 over 8. So our answer in this problem would be 15 over 8 because it does not reduce. 15 is opposite and 8 is adjacent. Now, if we were talking about angle W, then our answers would have been a little bit different. So you really need to look at your angle that it tells you and then figure out opposite over hypotenuse, adjacent over hypotenuse, or opposite over adjacent. All right, so cosine cosine is adjacent over hypotenuse. We're looking at angle U. The hypotenuse is always the hypotenuse, and the right angle always points to what the hypotenuse is. 45 is opposite U, and 28 is adjacent. So we are going to use 28 and 53. That does not reduce. So 28 over 53 is your answer. Sine C. Sine is opposite over hypotenuse. Here is C. Here is opposite. Here is hypotenuse. So 2 over 3 does not reduce. That is your answer. G. Sine G, you're going to find your opposite, and you're going to find your hypotenuse and put them over each other and reduce. But wait. 74 is the hypotenuse, but this side right here is your opposite, and we do not know at this time what the opposite is. So we have to go back to unit Q on the Pythagorean Theorem and use the Pythagorean Theorem, okay? So a squared plus b squared equals c squared. I don't know a. I know b is 24. I know c is 74. I'm going to get a calculator. 24 squared is 576. 74 squared is 5476. What are we going to do now? We're going to subtract. And get 4,900. And then square root it and get 70. So x is 70. So our opposite over hypotenuse is 70 over 74. Since both of those are even, then they reduce. If they're even, then they reduce at least by 2, and that would be 35 over 37. So this is your answer. I shouldn't have squared that other red part. All right. We're looking at y. Here's your hypotenuse. This is adjacent, and this is opposite. Cosine y is adjacent over hypotenuse. Your adjacent is 2 square root of 15. Your hypotenuse is 2 over square root of 23. Now I'm going to look real quick, because I know that you guys are going to love doing this if you didn't have a calculator. So I'm going to plug this in and see if it actually, and it did work. So I hit fraction bar, I put this on top, I put this on bottom, I hit enter, and it did give me square root of 345 over 23. Okay, so that's what your answer is going to be. If you use a calculator and you get a decimal, it says do not round. So if you get a decimal, that's not what you're going to be putting. This is simplified rational form. Now, if you are wanting to know how we got that, 2 square root of 15 over 2 square root of 23. Both 2's are on the outside, so those cancel out, but you're not allowed to leave a square root on bottom. So whatever your square root is, square root of 23 over square root of 23, and I suppose 15 times 23 is 345. And if you take the square root of 23 and the square root of 23 and you multiply them together, you're just going to get 23 because the square roots cancel each other out. So that's how the calculator got that. Tangent P, here's P, here's your hypotenuse, here's your adjacent, and here's your opposite. And tangent is opposite over adjacent, and we don't know our opposite, so again we're going to have to use the Pythagorean Theorem. X squared plus 3 square root of 6 squared equals 3 square root of 11 squared. Square root of 6 times square root of 6 is 6 times 9 is 54. Square root of 11 times square root of 11 is 11 times 9 is 99. You can put those in the calculator and see what you get. 99 minus 54 is 45. And then you square root that. 3 square root of 5. So our opposite is 3 square root of 5. Now we're ready to do the problem. If our opposite is 3 square root of 5 and our adjacent is 3 square root of 6, again, you can throw that into the calculator. Or if you don't have a calculator, the 3's will cancel out. You're not allowed to leave square root of 6 on bottom. So we put a square root of 6 on top and on bottom. 5 times 6 on top is 30. That will not simplify anymore. Square root of 6 times square root of 6 is 6. So square root of 30 over 6 is your answer. Here's D. So this is opposite, this is your hypotenuse, and this is your adjacent. We're looking for cosine D, because cosine is adjacent over hypotenuse. Again, we don't have our adjacent, so we have to use the Pythagorean Theorem. So x squared plus 1 squared equals the square root of 2 squared. X squared plus 1 equals square root of 2 times the square root of 2 is 2. Minus 1, x squared equals 1, and if we take the square root of 1, we get 1. So our adjacent is 1. If our adjacent is 1 and our hypotenuse is 2, or square root of 2, I'm sorry, plug that in the calculator, or square root of 2 over square root of 2, 1 times the square root of 2 is 2, square root of 2 times the square root of 2 is 2. Those two 2's do not reduce because the top 2 is under the square root and the bottom 2 is not under square root, so those cannot cancel out. I'm going just a second. Okay, I'm going to go real fast because I have 96 seconds. So we're looking at W, opposite, adjacent, hypotenuse. 25 plus 19 is 44. Square root of 44 is 2 square root of 11. So our hypotenuse is 2 square root of 11. Sine W equals opposite over hypotenuse, which is 5 over 2 square root of 11. 2 square root of 11, which is 10 square root of 11 all over 44, which reduces to 5 square root of 11 over 22. I do not have time to do the last two. Go to the next video.